Hello everyone, myself Hans. Today we are going to solve the given problem. Problem is based on Jacobians for the topic mathematical methods. Here in the question, if u1 is equal to x2 x3 upon x1 and u2 is equal to x3 x1 upon x2 and u3 is equal to x1 x2 upon x3, then we have to prove that del of u1 u2 u3 upon del of x1 x2 x3 is equal to 4. Let's solve the problem. Given u1 is equal to x2 into x3 upon x1 and u2 is equal to x3 into x1 upon x2 and u3 is equal to x1 x2 upon of x3, and we have to prove del of u1 comma u2 comma u3 upon del of x1 comma x2 comma x3 is equal to 4. We have to prove that. Further we have to solve. First let taking left hand side, that is del of u1 u2 and u3 upon del of x1 comma x2 comma x3 is equal to, this is given by del u1 upon del x1 and del u2 upon del x1 and del u3 upon del x1. Further we have to write for x2, that is del u1 upon del x2 and del u2 upon del x2 and del u3 upon del x2. Further we have to write for x3, that is del u upon del x3 and del u2 upon del x3 and del u3 upon del x3. Further we have to find the value of del u upon del x1 and del u upon del x2 and del u upon del x3, and we have to put in the determinant using we have to find the value using u1 u2 and u3. Further we have to find, first we have to find del u upon del x1. Here is u1 is equal to given by x2 into x3 upon x1 and differentiating partially with respect to x1, taking x2 and x3 is constant. First we write x2 x3 as a constant and differentiating x1 with respect to 1 upon x1, that is del of del x1 and 1 upon of x1. We can also write, that is x2 into x3 and del of del x1 respect, that is x1 is taken into numerator, that is x1 power minus 1, and using the formula, that is del of del by x of x power n, that is nx n minus 1. We use the following formula, that is x2 into x3 and we have to write x1 to power minus 1, that is minus of 1 into x1 and minus of 1 and minus of 1. Further we have to write, that is minus of x2 x3 upon x power minus 1 and minus 2, minus 1 and minus 2 minus 2 taken into denominator, that is x power of 2, x1 की power 2. This is the value of del u upon del x1. Further we have to find, we can write here, that is the value is x2 x3 upon x1 का whole square. Further we have to find del u upon del x2, del u upon del x2, and this is given by differentiating u1 differentiating partially with respect to x2, taking x1 and x3 is constant, that is differentiating x2 with respect to x2 is 1, that is x3 upon x1. Further we have to find del u upon del u1 upon del x3, again differentiating u1 with respect to x3 partially, taking x2 and x1 is constant, that is differentiating x3 with respect to x3 is 1, and remaining is x2 upon x1. Further we have to find del u2 upon del x1, that is the value of 2 differentiating partially with respect to x1, taking x2 and x3 is constant, and differentiating x1 with respect to x1, that is 1, then remaining is x3 upon x2. Further we have to find del u2 upon del x2, the value of u2 differentiating partially with respect to x2, taking x3 and x1 is constant, that is taking x3 and x1 is constant and differentiating with respect to x2, that is 1 upon of x2. We have to take into numerator, that is x3 into x1, and del of del x2 we can write x2 की power minus of 1, and again using the formula del by del x of x की power n, that is nx and minus 1, that is we can also write minus is taken into outside, that is x3 . Further we have to solve, that is x minus of x3 x1, and we have to take x2 की power minus 1 and minus 1, that is minus of 2 taken into denominator, that is x2 की power square. This is the value of del u2 upon del x2. Further we have to find del u2 upon del x3, the value of u2 differentiating partially with respect to x3, taking x1 and x2 is constant, and we have to differentiating x3 with respect to x3, that is x1 upon x2, and further we have to find del u3 upon del x1, that is the value of u3 differentiating partially with respect to x1. Here is x1 differentiating partially with respect to x1 is 1, and x2 and x3 is taking constant, that is x2 upon x3, and further we have to find del u3 upon del x2. Again, the value of u3 differentiating partially with respect to x2, taking x1 x3 is constant, and differentiating x2 with respect to x2 is 1, then remaining is x1 upon x3. Further we have to find del u3 upon del x3. Again, the value of u3 partially differentiating with respect to x3, taking x1 and x2 is constant, that is x1 x2 is taking constant, and del of del x3 differentiating 1 upon x3. We can differentiate, that is x1 x2 and del of del x3, and taking x3 into numerator, that is x3 की power -1. Again using the identity del of del by del x of xn, that is nx and -1. Here is n is minus of 1. We can take into back, that is x1 minus of x1 x2 and x3 की power -1 and -1, that is minus of 2 taken into denominator, that is x की power minus of 2 plus of 2. This is the value of du3 upon del x3. Further we have to put the value in the determinant. First you have to put del u upon del y1. We can also write here, one second, then we have to put, this is the value of del u upon del x1, this is the value of del u upon del x2, this is the value of del u1 upon del x3, and this is the value of del u2 upon del x3, and this is the value of del u2 upon del x2 का, one second, del u, this is del x2, and we have to put, first we have to put the value of del u upon del x1, that is del u upon del x1 is given by minus of x2 into x3 upon x1 का whole square. Further we have to put del u upon del x2, and del u upon del x2 is given by x3 upon x1. Further we have to put del u upon del x3, and this is given by x2 upon x1, and we have to further put del u2 upon del x2, that is del u2 upon del x2, del u2 upon del x1, that is x3 upon x2. Further we have to put del u2 upon del x2. Del u2 upon del x2 is given by minus of x3 x1 upon x2 का square. Further we have to put del u2 upon del x3, that is del u2 upon del x3 is given by x1 upon x2. Further we have to put del u3 upon del x1. Del u3 upon del x1 is given by x2 upon x3, and del u3 upon del x2 is given by del u3 upon del x2 is given by x1 upon x3. Further we have to put del u3 upon del x3, that is this is given by minus of x1 x2 upon x3 का स्क्वायर. Further we have to solve the determinant. Further we have to solve the determinant, that is taking common x1 square. This is r1 and this is r2 and this is r3. We have to take common, taking common x1 from r1, x1 square taking common from r1 and taking x2 square common from r2 and taking x3 square common from r3. We have to take common, that is, once again, we have to take common, that is x1 का square from r1 and x2 का square from r2 and x3 का square from r3. Then remaining in the determinant is, here we have to common x1 का square, that is minus of x2 x3, and from here we have to take x1 का square. Then we have, here is x3 and x1. Further from here, that is we can also taking common x1 का square. x1 is already present, that is we can also write x2 x1 up. In the second row we have to take common x2 का square. Here is one x2, that is we can also write x3 into x2, and for the this row we have to take common x2 का square. Then remaining is here x3 x1, and from here we have to take common also x2 का square, that is x1 x2. For the third row we have to take common x3 का square, that is x2 into x3, and from here that is x1 x3, and from here x3 का square is common, and remaining is minus of x1 x2. Further we have to solve the determinant on taking operation, that is r1 goes to r1 plus of r2. This is the r1 and this is r2 and this is r3. We have to take operation r1 replacing r1 plus r2. Then we have to write that is x1 का स्क्वायर into x2 का स्क्वायर into x3 का स्क्वायर. Determinant of on operation, this is r1 replacing r1 plus r2, that is r1 plus r2. We have to plus, that is x2 and minus of x2 and plus of minus of x2 into x3 and plus of x2 into x3, that is 0. And further we have to add x3 into x1 and plus of and minus of x3 into x1, this is also 0. And from here that is x2 x1 and x2 x1, that is 2 times of x1 x2. Further we have to write as it is, that is x3 x2 and minus of x3 x1 and x1 x2, and third row is x2 x3 and x1 x3 and minus of x1 x2. We have to open the determinant with respect to this, that is this row is eliminate. We have to take, that is x1 का square x2 का square into x3 का square into 2 times of x1 x2, and we have to cross multiplication with, that is x1 x3 and once again x1 x3 once again we have to take one more operation. This is x1, taking one more operation, that is this is r1 and this is r2 and this is r3. We have to take operation. We have to take operation here, that is r2 replacing, one second, r2 replacing r2 plus r3. We have to take operation, that is x1 का स्क्वायर x2 का स्क्वायर into x3 का स्क्वायर. In the determinant we have to take operation, that is first row is unchanged, that is 0 0 2 x1 x2 into, we have to change in operation in r2, that is r2 replacing r2 plus r3, that is here is x3 x2 and x2 x3, that is 2 times of x2 x3, and from here we have to minus of x3 and plus of x1, and from here x1 x3 this is 0, and further we have to also for the third x1 x2 and minus of x1 x2, this is also 0. Then the remaining is x2 x3 into x1 x3 and minus of x1 into x2. Further we have to take operation. Once again we have to take operation, that is r3 replacing r2 times of r3 plus of r1. R3 replacing 2 times of r3 plus r1, that is then first row is unchanged, that is x1 का स्क्वायर x2 का स्क्वायर into x3 का स्क्वायर. Determinant of first row is unchanged, that is 0 0 2 times of x1 x2. Second row is also unchanged, that is 2 times of x2 x3 into 0 and 0. For the third row we have to take operation 2 times of r3, that is 2 times of x2 x3 plus of r1, that is 2 times of x2 x3, and we have to take add r1, that is r1 is 0, then remaining is 2 x2 x3. Further we have to 2 times of r3, that is 2 x1 x3 2 x1 x3 plus of 0, nothing to change, this is. And for the this function r3 2 times of x1 x2 and 2 times of r3, that is 2 times of minus 2 times of x1 x2 plus of 2 times of x1 x2, that is 0. Further we have to open the with respect to this, that is this row and this row is eliminated, that is x1 का स्क्वायर x2 का स्क्वायर into x3 का स्क्वायर into of 2 times of x1 x2 into on cross multiplication with the 2 2s are 4 2 2s are 4 x1 x x1 x2 and x3 का whole square on cross multiplication with this is 0. Then further we have to solve. One second, some this is 1 upon taking one common, that is x1 का square x2 का square into x3 का square. This is 1 upon this is 1 upon of x1 का square into x2 का square into x3 का square. Further we have to cancel out, that is one second, 2 2s are 4, 2 times is already present. That is x1 का square. We can also write that is 4 2s are 8. We have to prove 4. This is 0 and R3. R1 is 2x1 x2. 2 times of x1 x2, that is 2 2s are 4, 4 2s are 8. We have to further write, that is 1 upon of x1 का square into x2 का square into x3 का square into of 8, and here is x1 का square x2 का square and x3 का square. This is eliminated and the remaining is 8. 2 is some operation is mistake. 2 is coming from R2 operation. Here is 2 is not changed. That is, then we have to get 4, and which is equal to 2 RHS. This is the required solution of the given problem.